Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.122. While solving this problem, we will be using Kirchoff's current law. According to this law, cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.122. Find the power supplied by dependent current source in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find power supplied by this dependent current source. In order to calculate power supplied by this dependent current source, we should have at least two parameters. One is current through this dependent source and other one is voltage across this dependent source. Right now no parameter is specified, so first of all we will try to solve this network in order to get voltage across this dependent source as well as the value of current through it. Later on we will be able to calculate power supplied by this dependent current source. So in order to solve this problem, we will assume voltage V is appearing across this parallel network with this specified polarity. Similarly, we will assume current I is flowing through this branch in downward direction. Now, in order to calculate the value of current I through this branch, we will divide voltage with the total resistance of this branch. Because these resistances are connected in series connection, so their total resistance will be equal to the sum of all resistances. 10 plus 10 plus 5 will become 25 ohm. And the value of current will be voltage V divided by 25 ohm. Similarly, we will find the equation of voltage Vx because current through this dependent source is depending upon the value of voltage Vx, and voltage Vx is product of I and 5 ohm. Here I is replaced with its equation, that is V divided by 25 ohm. Now take the product of V divided by 25 ohm and 5 ohm. This 25 ohm will cancel out with 5 ohm and the equation of Vx will become V divided by 5 ohm. Now we will write Kirchoff's current law equation for this particular node in order to calculate the value of voltage V. On this node only one current is entering, that is 2 ampere, while two currents are leaving, one is I and other one is 0.4 Vx, the current of this dependent current source. Leaving currents are taken with negative sign while entering current is taken with positive sign. Now in order to further solve this equation, we will replace current I and Vx with their respective equations. I is replaced with V divided by 25 ohm while Vx is replaced with V divided by 5. Now in order to omit denominator values, we will multiply this equation with 25 on both sides. Product of 0 and 25 will become 0. On the other hand side, product of 2 and 25 will become 50. While this 25 will cancel out with the product of 25, only minus V will left. Here the product of 25 will cancel out with 5 ohm in denominator, only 5 will left and that 5 will multiply with 0.4 and V. So the equation will become 50 minus V minus 0.4 multiplied by 5V equal to 0. Now take the product of 0.4 and 5, it will become minus 2V. This minus 2V and minus V will become minus 3V and place this minus 3V on the other hand side of equal to make it positive. So the equation will become 50 equal to 3V. In order to calculate the value of voltage V, we will divide on both sides with 3. So the value of V will be 16.67 volt. We have calculated the value of voltage V that will be appearing across this dependent current source as well. Now we have to find its current value, that is depending upon the value of voltage Vx. And voltage Vx can be easily calculated because now we have the value of voltage V. So place value of voltage V inside this equation. Vx will be equal to 16.67 volt divided by 5 ohm. So the value of voltage will be 3.334 volt. Now we can calculate the value of current through this current dependent source because it is 0.4 times Vx. So the product of 0.4 and 3.334 volt will become 1.33 ampere. So the current of this dependent source is 1.33 ampere while voltage across this dependent source is 16.67 volt. We are able to calculate power of this dependent source, that will be the product of voltage across it and current through it. So the power of this dependent source is 22.17 watt, and this power is being absorbed by this dependent source because current is entering from positive terminal and leaving from negative terminal. So this was exercise problem number 2.122. Thank you. See you again in next video.